Welcome to qnawire.
So now we'll work on problem 48 from chapter 17. In this problem, we are asked to calculate the pH at the equivalence point in titrating 0.1 molar solutions of each of the following with 0.08 molar NaOH. So in the first part A, we're asked about titrating with HBr, hydrobromic acid. Now for this one, we don't need to do any calculations because we have a strong acid being titrated with a strong base, so the pH will equal 7 at the equivalence point. So we'll move on to part B, where the acid which we're titrating against is chlorous acid, HClO2, and the concentration is 0.1 molar. So here, we can go ahead and draw the equilibrium that will occur when the acid has been neutralized. And so when the acid has been neutralized, the only thing that will be left is the conjugate base, ClO2 minus, which will react with water to give an equilibrium product of the acid again and OH minus. So to know the concentration of ClO2, which is necessary because we need to know the initial concentration, we need to know this initial concentration here. What we can do is we can multiply the concentrations by each other. So we have 0.1 times 0.08, and this here will account for the volume. So we add on the bottom where the total concentration will be equal to the sum of these two, because that's what we were adding into the sample. And this is equal to 0.044 molar. So that's our initial concentration here. We have none of this. This is X. So we can go ahead and write the Kb for ClO2 minus, which is we can get from the Ka. So Kb is equal to 9.09 times 10 to the 13, negative 13, which is equal to X squared over 0.044 minus X. We disregard the negative X because we have a weak base here, and the X value is 2 times 10 to the minus 7, which we can take the negative log of to get POH as being 6.70. And then from that we can get pH being equal to 7.30. So for part C, the acid we want to work with is benzoic acid. So the same concentration as before. So to find the concentration of the conjugate base, benzoate, which is C6H5COO minus, we multiply the initial concentration of the base times the acid, or vice versa, and then we divide by the addition of them. and we get a value same as before, 0.044 molar. So now our expression will be the same as on the last page with a different KB. So this time the KB is 1.59 times 10 to the minus 10, which we get from the Ka. We're dividing 1 times 10 to the minus 14 by the Ka of benzoic acid. And we get x squared over 0.044 minus x gives an x equal to 2.64 times 10 to the minus 7, which if we take the negative log, we get a POH equal to 5.58, and finally a pH of 8.42.